All right, hi all. The first thing we're going to talk about today is Target 1C, which has to do with synthetic division. Okay, so I'm going to break up the notes 3 different ways today. The first is how to use it. Sorry. There we go. The first part is we're going to learn how to use it. Okay, we're going to talk about how it implies if something is a factor or not. And then the last part is we are going to show the remainder theorem. So we are going to break it up into 3 different pieces. Okay, so let's go ahead and start with how to use synthetic division. So, how? So the setup is pretty simple. What you would do is you put your coefficients from your polynomial up here. Your 0 goes on the outside. Okay, so that is just the setup. Now, once you set it up, you're going to go ahead and do a couple of steps. The first step is to bring down the first number. Okay, so I'm going to bring down whatever that is. So I have a variable written there, but you'll see the coefficients later. Then what you're going to do is you are going to basically take steps 2 and 3 and you are going to repeat them. So what you're going to do is you're going to take this bottom number and multiply by the 0. Okay, after you do that, this will then go in this spot right here, so in this blank. Then you will add vertically. So you'll add that coefficient, that number, and you'll continue to repeat until you're done. When you finish and you take a look at the bottom row, this last number represents your remainder. So we will go ahead and do an example of it already set up, and then we will set it up from another problem. So just how to use it. So I'm going to make up some numbers here, and I'm going to put a number on the outside. Okay, so let's go ahead and practice it. The first step says to bring down the 1. Okay, so I did the first step. Now, the next step says to multiply the bottom number by the 0. So the bottom number is 1, and again, my 0 is 2. So I'm going to do 1 times 2, which is 2, and then I add it vertically, so negative 3 plus 2. Now I take my new number of negative 1, and I multiply negative 1 by 2, which gives me negative 2. And then I add vertically, so 5 plus negative 2 is 3. Then I take 3 and I multiply it by 2, which is 6. And then I add vertically, so negative 9 plus 6 is 3, which means this is my last number and that is my remainder. Okay, now we'll talk about why that's important later. So think about when you used to do long division. If I took 8 divided by 2, I know that is 4 with no remainder. But now if I take 9 divided by 2, that is also 4, but with a remainder of 1. So every time you divide, you are going to have some version of a remainder, whether it's nothing or a number. And we'll talk about what that means very soon. Okay, so now let's go ahead and practice using it in a different capacity. So let's go ahead and take f of x equals x cubed plus 4x squared minus 5x plus 3. So, and we're going to take this polynomial and we are going to divide it by x plus 2. So a couple of key points here that you need. The first key point is you always need to make sure your polynomial is in standard form, and that it has all of the terms. So I have an x cubed, x squared, x, and x to the 0th. I'm good. Okay, So now using this, my coefficients will be 1, positive 4, negative 5, positive 3. So when I go to set up my synthetic division, I have 1, positive 4, negative 5, positive 3. So now based on this, this is called my factor of x plus 2. I need to turn this into a 0, which means x equals negative 2. Right? We talked about if you were to graph it, it occurs at negative 2, or you take the opposite of the sign. So that would go on the outside. Okay, so that is just the setup. Now from here, we're going to have to go through our steps. Our first step is to bring down the 1. Then I multiply 1 by negative 2. Then I add. I take 2 and I multiply it by negative 2. Then I add. I take negative 9 and multiply by negative 2. Then I add. Okay, so notice, every single time, you're always multiplying by your 0 here. So, this last number represents my remainder. All right, so now the next part of the lesson. Okay, so we said we're going to break the lesson in 3 parts. So the third part is to determine if something is a factor. So if blank is a factor of a polynomial. So like the blank could be, is x plus 1 a factor? Is x minus 7 a factor, right? So how do we determine if something is a factor or not? If the remainder equals 0, then yes, it is a factor. Okay. Now why does that make the case? If I ask you what is 8 divided by 2, and you tell me it's 4 with no remainder, that would mean 4 is a factor of 8, which is a true statement. Okay, and so if your remainder is not 0, it is not a factor. So let's go ahead and practice the test. Is something a factor or not? So, is x plus 3 a factor of f of x equals 2x cubed plus 5x squared minus x plus 6. Okay, so to check if it's a factor, we are going to have to divide to find out what the remainder is. Okay, so this is what we call using the remainder theorem. So I'll say that again. We're going to have to divide to find out what the remainder is. So let's go ahead and set it up here. So my coefficients are 2, positive 5, negative 1, positive 6. Where am I coming up with these? 2 is here, positive 5, negative 1, positive 6. Again, my polynomial is in standard form. Okay. Now, based on this factor, I need to take the opposite to use the 0. So the 0 would be at negative 3. Okay. Now, let's go ahead and practice using synthetic. So I bring down the 2. And then again, my steps are to multiply and add. So 2 times negative 3, add. Negative 1 times negative 3, add. 2 times negative 3, add. And again, I go through this quickly because I know my multiplication facts pretty quick and addition pretty quick. If you need to use a calculator, make sure you have that out. Okay? And remember, the last number represents my remainder. So I get a remainder of 0. So because my remainder of 0, my conclusion is x plus 3 is a factor. So what this would mean is that if I were to go and graph this equation, you would find out that you would have a 0 at negative 3. Pretty interesting. Okay, so let's go ahead and go into the last part of today. So the last part of today is to divide out a factor and what would happen if I get a remainder. So the last problem, I got a remainder of 0. Now what would it look like if I didn't get a remainder of 0? Okay, so let's go ahead and divide. Let me grab a problem. F of x equals x cubed minus 2x plus 5 by x plus 1. Okay, so let's go ahead and do the whole shebang. So we're going to divide it, and then let's see what ends up happening and what creates. So let's set up our dividing. Our coefficients are 1, 0, -2, +5. Now, I threw in this example real quick because in this case I have a 0. Why is there a 0 as a coefficient? So I am missing the x squared term, so I have to put a 0 in place of that slot holder. Okay? And using this, when I solve it, I get x to be -1. So -1 goes on the outside. So let's go ahead and go from here. I drop down the 1. 1 times -1, I add. -1 times -1, I add. -1 times -1, I add. And so 6 is my remainder. So what this means is x plus 1 is not a factor. So what do I end up getting when I divide? So what I end up getting is I will get a new polynomial. I will get a polynomial from dividing this out. Okay? So from dividing ... I get, now I have to turn this into what I will end up with. So this part here is my new set of my polynomial, and 6 is my remainder. Well, how do you write a remainder? Well, you're used to writing a remainder as R6, which is not true. Okay, you write a remainder by having it 6 over what you divided by. So this is your remainder. And the bottom would be what you would divide by. So we've been dividing by x plus 1 in this problem. Okay? It's by your divisor. Now let's build a polynomial. So when you're building a polynomial, it goes constant. It goes constant. It goes your x value. It goes x squared. It goes x cubed. It goes x to the 4th. But now when I take a look at this particular equation, I have a -1 as my constant. I have a -1x as the next term, and then I have a positive x squared. I do not continue on because I don't have an x cubed term or an x to the 4th term. So this is what I end up getting when I divide my polynomials. Okay?